right, guys, we are back. And today, what we're going to focus on is networking. Believe it or not, guys, we are a little less than halfway there. Okay, we're moving along pretty well. I'm actually really happy with the progress. And today, what we're going to talk about is 2.2 compare and contrast common networking hardware. Believe it or not, I think today I can actually get this video under 10 minutes. So let's go ahead and try to get through this information. Okay, this one's rather simple because this was 2.2 compare and contrast common networking hardware. Okay, and I wanted to go ahead and establish this right from the get-go. Ask yourself, what layer of the OSI model would this device fit? Okay, you need to start having this in the back of your brain. It's going to help you tremendously when it comes to troubleshooting. It's going to help you tremendously when it comes to visualizing how data is moving from one computer to another computer, so on and so forth. Okay, and we're going to actually focus on this and keep this little framework all the way through the presentation, which I honestly think it brings a lot of value and it gives you an idea of where you are. It helped me. Hopefully it helps you. So let's go on to the first thing. And I just want to let you guys know, we're going to talk about routers and switches. And I have a quick little story. When I was barely studying this, or I didn't know this at all, I remember being asked, hey, what's the difference between a router and a switch? And I genuinely said, oh, that's simple. A router routes and a switch switches. And the guy looked at me like I was a you know what. And, I don't blame him, but by the end of this video, I promise you, you're going to have a better idea of what exactly a router is and what exactly a switch is and how they fit within the OSI model and how they fit within the IT world. Okay. So router is basically a layer 3 device. Okay. Let's go to our OSI model 1, 2, 3. So we know we're dealing with the network layer. Network layer is the same as the internet layer with regards to TCP model. Okay, and let's see what we have in our notes. They use IP addresses. Here's the key word: logical IP addresses to route. They connect different networks. Okay, so as you guys can see here, we actually have network A and we have network B. Okay, in order for network A to communicate with network B, you need a router. In order for network A to communicate with the internet and try to go ahead and download something from the internet, you're going to need a router. Okay. Network A, you can have 100 different computers and connect it to a switch. Okay. And all those computers within network A could technically communicate with each other. But network A, none of these computers that were in network A, even if you had 100 of them, would be able to communicate with another network unless you had a router. The router puts a logical IP address, which goes ahead and configures and packs the packets, so to speak, to that IP address. Okay, so just realize that a router is a critical component, right? Without a router, you would only have access to your particular network. You wouldn't be able to communicate with other networks, right? And network A, you can say this is your home network, right? And network B can be Google, right? Obviously, if you had a straight line to Google, that'd be a little different. But you see what I'm saying? Network A would be like a office or what have you. Network B can go ahead and be something that you're trying to find on the internet, or it can be another office that you have in another location. In order for A to communicate with B, you need a router. Okay, and that's dealing with layer 3, and that deals with a logical IP address, which means you can technically change I know it's blurry, but it's 192.168.2.2. You can change this address. That's no problem because it's just logical. It's just an idea. Okay, you can configure this IP address to almost whatever you want, so to speak. Okay, let's go on to what is a switch. So switches on the other hand is now a layer 2. So we're at the data link layer or at the link layer, just depending on which model you're looking at. Okay, and they use MAC addresses. MAC addresses are physical. I like to think of MAC addresses as social security numbers. They follow you wherever you go. Okay, and same thing with a MAC address. When a device is constructed, half of the MAC address is basically predicated upon the manufacturer. Okay, and the cool thing is that you can start looking at MAC addresses and say, hey, this MAC address is associated with Lenovo. This MAC address is associated with Dell, right? Because half of the MAC addresses does come from the manufacturer. The other half comes from, I think it's the IEE. I'm not sure, but I do know that for a fact that half of the MAC address does come from the manufacturer. And within the switch, guys, this is what I was referring to back then. Okay, and this is the symbol of a switch, and this is the symbol of a router, and you get a switch to communicate within the same network. So now A can talk to B, B can talk to C, C can talk to A can talk to C. So now you go ahead and you're starting to have this network, right? But if this here will never be able to communicate with another network unless it has a router. We're just going to leave it at that. Okay, they connect devices on the same network. Comptia does want you to know what's the difference between a managed and an unmanaged. That's very simple. Managed means you've configured it. Okay, because when switches, if you buy a switch, if you buy a brand new switch from Cisco right now and you order it and it comes to your house, you can open the box and it's literally plug and play, and that would be unmanaged. Once you start tinkering with it and start changing its name and start creating VLANs and start creating some rules or some security features on that switch, now it's managed. Okay, so a switch technically out of the box without it from coming straight from the manufacturer is unmanaged. Okay, it's plug and play. Once you start managing things and start setting passwords and start setting VLANs and start doing the things that you want it to do, now it becomes managed. Okay, let's go on to access points. So access points is really simple. It's layer one, layer two. So we're dealing with the physical and we're dealing with the data link layer or just the link layer. Okay, and this basically, this little device here is what gets the wireless signals. Okay, it gets the wireless signals and it gets it into a wired. Okay, so this right here is what basically what allows Wi-Fi to essentially happen, right? Because you don't see the Wi-Fi, you don't see the cable plugged into your device. There's the wireless signal. This takes that wireless signal, it does its little computation of ones and zeros, and it sends it through the wire. That wire is more than likely connected to a switch. That switch is more than likely connected to a router. That router can go ahead, is more likely connected to your modem at home, or it can be connected to another router, and the device travels. So you can start to see how this OSI model starts to work, so to speak. Okay, so access points, just think about Wi-Fi, and it deals with wireless signals to wired signals. Okay, SSID stands for server set ID. If you want to call your internet Starbucks coffee, then you would change the SSID to Starbucks coffee. If you want to change it to the Smith's home, your SSID would be the Smith's home. So this is exactly the service set identification, what you're broadcasting, what you name your network. Let's go to the patch panel. I'll be honest with you, I never really dealt with the patch panel, but the key point here is organization and management of cables. If you literally work at a server farm, or if you're working at a high-end database, so to speak, and you have 100 servers, and imagine 100 different wires connected to the servers and then all the other accessories. Okay, there's a lot of things going on. You want to have a high level of organization. Here's an idea. One is associated with server one, two is associated with server two, three is associated with server three, so on and so forth. So if you're saying, hey, there's a problem with server 15, hey, let's go ahead and diagnose this OSI model. Let's start with the very first thing, the physical layer. Let's go test the cable. Let's go test the port. Okay. And now you can go ahead and start to see that organization pays off, and you can go ahead and have a better day at the office, so to speak, when you have organization, and the patch panel is what helps you do that. Okay, brings us to word of the day. Word of the day is mini DIN or PS2. This, guys, is what they used to use to connect keyboards and mouses. As you can see, this is part of the motherboard here, or you have a cable as such. It's basically a 6-pin. This would be considered the female, this would be considered the male. Okay, and that was basically what we use to connect keyboard and mouses. So if you see something like this, like identify this, you know that it's either going to be called the mini DIN or a PS2, or maybe you're out in the field and then they're saying, hey, we need that old school mouse connector. Oh, you're talking about about the mini DIN or PS2. Okay, got it. Okay, so just making sure that you know this right here. More than likely, you're not going to see it nowadays. USB has definitely taken over, and this is much rather older technology, but it's something you should see and know. Firewall. Okay, so this is definitely a big topic of discussion nowadays, especially with everyone being hacked every other day. Firewall. What exactly does a firewall do? Okay, so first we're going to talk about the layers in which we're operating, and it really honestly depends on the firewall because now there's so many generations of firewall, but traditionally a firewall was working at layer 3 or 4. Layer 3 or 4, the OSI model, is the network layer or the transport layer. Remember, the network layer, we just learned that it deals with IP addresses. Okay, so you can start to block certain IP addresses, or you can allow certain IP addresses to come in. When it comes to firewall, I like to think of it as the bouncer at the club. It goes ahead and makes the rules. It doesn't make the rules, but you configure the rules into the firewall, and the firewall goes ahead and enforces the rules. Rules, think about rules both in and out of the network. So you can configure something coming in, you can set rules for things coming in, you can set rules for things coming out. Layer 3, we talked about that network layer. Transport layer, we literally made a whole 30-minute video about that previously, which deals with the TCP or what would be the UDP. Okay, and remember, those protocols are used to basically those protocols are used to manage how information is sent. Okay, and if you know if you know the application protocols and their port numbers, or if you know if they use TCP or UDP, you can start blocking those. A cool way to think about this would be like remote desktop protocol. Remember 3389. If you have a laptop with what would be critical information and you're saying, hey, let's reduce all vulnerabilities, remote desktop protocol, we're going to get rid of that so people can't exploit that, so people can't remotely log into this computer and see the information that we have and or mingle with the information. So that's one way of how you would use a firewall. Remember, it's basically rules. There's different types: hardware, software, network, host, cloud. And how exactly does it work? I pretty much just mentioned it. Packet filtering, state, proxy. Okay. There's a lot of things going on in here, but I think as long as you know that, hey, firewall is basically rules. It works at layer 3 or 4. That basically means that it's gonna go ahead and um, based on the configurations, it's going to implement those rules. Okay, so that's basically a firewall there. And as you guys can see, when it comes to the firewall and where you would place it on your network, firewall seems to be right here. Okay, and people have different preferences and whatnot, but you definitely want your firewall as close as you can to the default gateway. That way it goes ahead and actually protects, right? Fun fact, firewall actually came from the idea of what was built with a car, the engine and the passenger and driver side. You would want a firewall just in case the engine caught on fire. The passenger and driver would get some time to basically not catch on fire. So just think of it like that as well. Placement of the firewall. This isn't the time or place for this particular video. Just knowing exactly what it is and the general idea how it works, I think will go ahead and help you with regards to your Comptia A+. Next one is PoE, a power over Ethernet. So this is really big when it comes to IP phones. If you're working at an office where they have 20 sales agents and they need to go ahead and have phones, more than likely you're going to want to make sure that your switch is power over Ethernet. Okay, you don't necessarily just need only IP phones. It just happens to be IP phones are really popular, especially in office settings and whatnot. And you can save a lot of money compared to having to buy an adapter or power supply where you can just simply power it over the actual cable for the Ethernet, right? And it gets pretty cool because you can use that same cable to go ahead and connect to your computer. So then you would have your IP phone and your computer all connected back into the switch back to the router potentially back to the firewall. But nonetheless, power over Ethernet. Just realize that there's certain standards, 802.3. There's the AF, AT, More than likely, these are just going to tell you, hey, more power. We're able to produce more power within these standards, so on and so forth. Keyword here, though, I want you to make sure you guys know what exactly an injector is. So if you have a switch that is not power over Ethernet, you can go ahead and buy an injector, and the injector you would basically plug into the switch, and now you could potentially, if properly configured and installed accordingly, you can go ahead and have power over Ethernet. So injectors, associate that with PoE. PoE, think of power over Ethernet, more than likely IP phones. Let's go to a hub. So a hub, very simple. More than likely, you're not going to see one. Hub, old school switch, less technology. Okay, so before there was a switch, okay, or just think of the switch as an evolution of the hub, so to speak. I don't know if I'm allowed to say that, but that's the way I see it, because a hub was basically, it was dumb. Okay, it was literally dumb. It would just repeat exactly what it was being told. It didn't have anything along the sense of being able to read MAC addresses, or being able to block certain ports, or being able to have security features that we see nowadays in switches. It was literally just, hey, we need a hub because this cable's too long and we might not have a proper signal. Let's go ahead and get a hub so we can extend this cable, so to speak. Half duplex, anytime you see half duplex or full duplex, half duplex basically means it can only do one thing. It could either send information or it can receive information. So that's what half duplex means. Okay, so this device here can either send information or can receive information. It can't be parallel. It can't do both. It can't send and receive at the same time. Okay, and basically what I said, broadcasting, when you see broadcasting, that's basically what it is just literally repeating information. So right here, no real intelligence, so to speak, but nonetheless, pretty cool. Pretty cool technology. It's just like, hey, that's what we had at the time, and look where we are now. Old school switch, less technology. I mentioned that. Cable modem. If you ever go ahead and want to get internet, so you go and contact your service provider. Nowadays, they usually typically have all in one, so to speak. They'll have like your cable modem, then they'll have that in with the router, so to speak. You get a few cool devices, but a cable modem, okay, it's basically internet, data, coax cable to Ethernet. So what do I mean by this? You have your internet service provider. Your internet service provider, okay, so just think of AT&T is going to send data through a coax cable. That coax cable has the modem. Okay, it does its little magic and computing and its processing, and then you can go ahead and have a port with the Ethernet. You plug that port to the Ethernet, and now you can plug that into a switch. You can plug that into a router, firewall. You can plug that into your computer, so on and so forth. And now you have Ethernet. So that's what I meant by this right here. Internet. So you have AT&T is sending data. That data is gone through the coax cable. That coax cable can now, within its modem, okay, it now has Ethernet ports that you can utilize to connect to the internet. Okay, modem layer 1, 2, 3, physical layer, data link layer, and network layer. Typical home and small office devices usually come from ISP, internet service provider, hardware. Usually more than just one modem. Usually more than just a modem. Many devices in one. Okay, so just keep that in mind. But it's pretty simple. Let's go on to the next one. ONT, optical network terminal, layer 1, 2, and 3. We're looking at physical layer, data link layer, network layer. So this basically converts fiber optic signals into electrical signals for LAN devices. Okay, so now same idea that we have here, right? ISP, internet service provider, goes into OFC, okay, which goes into ONT, and now we go to Ethernet. Okay, so this device here, the optical network terminal, is I don't want to say an evolution of a modem, but it's the same idea. Is instead of, if your internet service provider has fiber optic cables, that means that's better, higher speed and data transfer that you can have. And in order for you to go ahead and utilize that, right, more than likely you're going to need an ONT, which allows the fiber optic signals. Okay, you got this little box here that goes ahead and does its magic, and now you can plug in your Ethernet, right, to plug back into your either your wireless, your access point, or plug into what would be your laptop, so on and so forth, your desktop. Okay, so if they're saying, hey, what device would you need if your internet service provider only has fiber only has fiber technology. Oh, we need an ONT, optical network terminal. Okay, that's going to help us turn that fiber optic cable signal to Ethernet cable signal. Okay, let's go on to the next one. NIC. Okay, network interface card. We're dealing at layer 1 or 2. Okay, this is hardware that allows a device to connect to a network. There's many different types. You have wired, wireless, fiber, integrated. Okay, so NIC, rather interesting how this little device here, okay, among with a whole bunch of other devices, but just how powerful this device here is with regards to going ahead and connecting us to the internet. Remember, we're at layer 1 and 2, physical layer, data link layer. Okay, so that is a NIC card. And lastly, guys, we're talking about SDN, software defined networking. This operates here on layer 3, 4, and 7. And this here, guys, is a networking approach via software, control management, programming. Keywords you should definitely know when it comes to SDN is controller, data plane, control plane. I'm going to be honest with you. This is something you shouldn't necessarily worry too much when it comes to your Comptia A+. I'm pretty sure as long as you know, hey, SDN stands for software defined networking. They're taking a software approach to going ahead and being able to program networks. Okay, as long as you know that for your Comptia A+. Okay, I think you should be okay. This is something definitely coming into the world, something you should highly pay attention to, especially if you're into your networking plus, especially if you're into what would be your CCNA. Believe it or not, when it comes to SDN, they literally have specific certifications for that that are really highly correlated to this information, which is the Cisco DevNet. But honestly, don't worry too much when it comes to the CompTIA A+. Focus on receiving and achieving your CompTIA A+ first, and then go on to the next thing. But definitely keep an eye out, especially if you're like me and you like to look things up. Hey, future SDN, or hey, where exactly is SDN now? That would be a good little homework assignment, so to speak, something to do when you're bored or whatnot. But nonetheless, I'll see you guys on the next one.